Okay, we will start. Thank you for attending. Today we're going to be talking about Python visualization libraries. So what tools we have available in order to do visualization on geospatial data. Okay. So today's notes going to be posted in the chat. Okay, so everyone is there. Okay, so we have the task to plot different geospatial data. And as we spoke last week in our talk about the different file formats that you encounter frequently in geospatial data science, basically raster and we saw this talk last time. Okay, raster and vector files. Yeah. Okay, so today we will continue. Since basically Python, the basic Python library for visualization is matplotlib, and and everything is derived from that. And also in Python, we have other options besides matplotlib, and I'll show you very generally. So we have, let me go to, okay, so these are the options of Python for doing visualization. The basic one is matplotlib, and if you go there, you will see all the different types of plots you can do, and all the documentation, whatever plot you want to replicate, you just go in and it will have all the code there in the example to produce a specific plot. And matplotlib usually use this pyplot sublibrary and numpy, and then this is the example of bar plots, and you have all the code there. So it's very, very easy to use. Okay, go back. And then depending on what type of data you have and what type of relationship you're looking for, you can create all these different types of plots. Let me just go back in general first. Okay. And then matplotlib, you can go into every detail of plotting using matplotlib, but then another library was built on top of matplotlib, which is called Seaborn. And Seaborn is basically less instructions or more easy instructions to make plots, but it's based on matplotlib, and you can create all these types of plots with Seaborn. These are general plots, relationship, Boolean plots, box plots, bar plots, scatter plots, heat maps, line plots, etc. So there were all the different types of plots you are used to doing with in statistics can be easily created with Seaborn. Yes, you have a question?
Carlos, okay, I see different types of plots. Well, what's the data structure so that they can do this? How should I put my data so that they can create these types of plots? How to find an example of that?
Okay, just let's say you take a line plot, and then you're just going to plot one axis versus the other one, or in this case, it's making several plots, and they're using this data set. So this data set may have all these different variables, or if you look at the Excel spreadsheet, you have different columns for different times, and then you are just plotting the file. These are just basic time plots. So the idea is to have a data frame in Python, or just like a table of values where you have the columns as variables and the rows as different values. And then you can create all the different types of plots. I don't know if I answered your specific question. So the first thing you should do is try to find a plot you want to do, and then try to adapt the plot to your data, assuming that you want to at least plot one column or one variable versus the rows.
Yeah, I'm still not sure, like, if I understand how, so, like, what's your data format? Like, so can I bring Excel columns in? And how do I do that?
You
Design
have
saying,
you have your Excel file, and then with pandas, pandas is the library from Python. You can read an Excel file into your working space, which is a Jupyter notebook. And then from that Jupyter notebook, you can decide what columns or what variables you want to plot. But with pandas, you can read Excel files, you can read CSV files, you can read files in other formats coming also in spatial data, for example. There's a workshop after this workshop on general data science. That's where we're going to go into the details with Matplotlib. Today, we are focused on doing geospatial data visualization. Okay, and then if you, those are the plots you get with Matplotlib and Seaborn are basically plots, non-interactive plots. If you are interested in doing interactive plots, then you can have Bokeh, for example, and also Plotly. Plotly and Plotly is commercial, so you can make interactive plots. But if you want to publish them for the general public, then you have to have an account, commercial account, to show your plots to everyone on a web server. Okay, well, you can do interactive plots, and then well, we can see some examples later. And then if you are coming from the R world, then in R you use ggplot2. So in Python we have ggplot and plot9, which is basically the same syntax as ggplot2. So one thing is, when you're doing data analysis, the analysis is one part. Once you have done the analysis, then you want to go to the next stage, which is visualization. And if you did your analysis in Python, then you can do visualization using the same scripts you use in R, using plot9 library or ggplot. Okay, we have an example here. Let me go very fast. So these are the nodes for the visualization in Python, and it will tell you all the different parts of a plot. And Matplotlib is the basic plot. Pandas, which is a library for data analysis, also have some plotting commands. So the types of plot you can do is relational plots, distribution plots, categorical plots, and multi-plot grids. The same thing with Matplotlib. And then when you're talking about visualization libraries, you need to know the names of the parts of the library of the graph or plot. So this will be the legend, for example. These are the ticks, the units. So these are the major ticks, and then you can have minor ticks. Then you can have the labels for the y-axis and the label for the x-axis. You can have tick labels. So you can define these are the spines or just the bounding box. Then you have line plots for different functions, different colors. You can use different markers. You can use dots. You can use triangles, squares, uh, asterisks, etc. And so these are the parts of a figure. And then you have examples here. This is how you call in matplotlib, always using NumPy because NumPy is in charge of all the mathematical functions. This is how you get relational plots, distribution plots, categorical plots, multi-grid plots, and then you can do something similar with Seaborn. These are the way you call the functions. Sorry, just messing around. Okay. Okay, regression plots, matrix plots, etc. Then you will find a Jupyter notebook on the bottom here with all the different examples, how to do the basic plotting using Python. Just for illustration, you have the code. This is how you import the libraries, all the visualization libraries. This Jupyter notebook compares different libraries for doing the same stuff. So let's say I'm just going to skip this part. Just basic.
Carlos, maybe we can notebook, like step through it, like actually like collab.
Well, you can open this notebook in Colab. I can share. It's on the. I can share them.
I'm in your notes.
Okay.
I like it too.
I'll just put it in the chat. Visualization. This is general. Yeah. Then once you open it in Colab, well, you can run it. But I will just read it. Okay. You can play with it later. So Seaborn, we imported the SNS and Plotly expressed as PX. Plot9, which is our ggplot2 syntax is there. So these are what you can do with matplotlib, just plotting functions, for example, plotting 4 functions. And every function will, by default, be plotted in different colors and different lines. And then you can, let's say, take out this. So you find the X variable, and then you define the figure. So this is like a object-oriented plots. So the plot from matplotlib pyplot will make subplots. We have the figure and the axis, and then we are going to add a grid. Then we're going to plot the first function, x versus sine of x, and we'll have a label. The second function is x versus x, label linear x versus x cubed, cubic x. And this is just a sum of different functions. And then you put the plotting limits for y. And then you can add different x ticks and put labels. And also add the labels for the x and y. And then the title, the legend, and then you get this plot. So this is not very different to what we see with other plotting programs like MATLAB or GnuPlot or even in Mathematica or Maple. So if you have a mathematical function, it's very easy to plot. Um, there's more than one ways of doing the same thing, and then to doing multiple plots. Um, like in this case, we're doing subplots, 2 plots, 1 row. This is the figure size. I'm plotting 2 x's. So the x1 is going to be, we were going to plot x1 versus y1, and second axis x2 versus y2. And we have a damped oscillator and the undamped oscillator, and those are defined with these functions. Okay, so we have a double plot. This is the damped oscillator, and this is the undamped oscillator, which is just like a cosine function. And then there's a second way of doing the same thing. 3-dimensional plots. You have seen this type of plot before, surface plots. You can do that. You can do that with Matplotlib. And then this is an example of reading a data set. We're reading this file, which is just a CSV file that has rows and columns. The columns are the variables. So we read that file name, which is over some GitHub account. I read that using pandas, PDS pandas, and then TF is going to be, is the data frame. Just think of a table. And we're going to print the first 5 rows of the data frame using the function head. We can use the info function to just show us the general properties of the data frame. So this data frame has 344 entries, has 7 columns. These are the names of the columns. These are the contents of the columns, and this is the type of object or floating number we have there. And going forward very fast, this is the type of plots I can do, several plots of different types. So I have a bar plot, I have scatter plot, and I have a box plot. And I can addition ticks, labels, and legends to the plot. So I end up with something like this. Okay. So my purpose is just show you how things are done with basic Python, and then we will jump to geospatial data, which is a little bit advanced. So these are basically types of scatter plots I can do. This is the penguins data set that has 3 species of penguins. And this is the flipper length versus the mass of the penguins. And then I can do correlation maps, heat maps. Basically, the correlation map is symmetric, so the diagonal is always ones, and the upper matrix, triangular matrix, is equal to the lower triangular matrix. So in a correlation matrix, you just need the lower triangular matrix for the information of the correlation between the variables. So this is how you can do it with Seaborn map. This is the value, the table of values. And then histograms, doing it with pandas, or you can do it with PyPlot, or you can do it with Seaborn, or you can do it with Plotly Express. Since I haven't run it, I don't have here the interactive plot, or I can do it with Plot9, and also using the same syntax as you use over ggplot2, so you get a histogram plot. Okay, bar plot, something similar for the different libraries. You can manage different options. And then bar plot with Seaborn, just one single line, you get the plot. The kernel density estimate functions. Then you can use different colors for different facets for the penguins. So I have the kernel density estimate for every species. I can do box plots with pandas, with Matplotlib, or with Seaborn. So seaborn are always more presentable. I can do a cat plot with seaborn. I can do violin plots where you have the distribution um, and you have the information of the box plots. The white dot here is just the median, and you have the first quartile, the second quartile, the third quartile, and the fourth quartile. And you can use the violin plots to show different properties. In this case, we're showing the body mass by species, by gender, and then scatter plots using pandas, scatter plots using matplotlib, scatter plots using seaborn. Okay, and then also seaborn again. So those are basic statistical plots you may do on your daily professional life when you're not handling geospatial data. Okay, so this notebook is part of another talk in the general data science visualization libraries in Python. So I'm gonna stop there and go back to what we were trying to achieve today. So I'm going to go back and go back. So that's the Jupyter on data visualization with Python. And then let's talk a little bit about the geospatial Python libraries. And we will see that matplotlib is still there. And matplotlib is used and NumPy are used to create new libraries. So CartoPy is for geospatial data, and it uses NumPy, Shapely, and Matplotlib. And then Geoplotlib is something that's just similar to Matplotlib, but it's dedicated for geospatial data. We will use some of them, not all, in our examples. So then there's IP leaflet, which is interactive maps in Jupyter Notebooks, and we are going to be using Folium. Folium is one of the libraries for that incorporates all the different properties. Besides, also you can call other libraries like OpenStreetMap, Mapbox, and other to create the tile sets or the background, and those you can create interactive plots. We will see an example with that in a couple of minutes. So that's Folium, and also we will find Ion Board, also for interactive geospatial vector data, and the EP leaflet for Stack. Stack is the spatial temporal assets catalog we saw in the previous two sessions. And we have Torch Geo. So this is based on PyTorch. PyTorch is just a library that can be run inside a Python environment for doing like deep learning tasks. Okay. So what I want to do in the next couple of minutes is jump into this Jupyter notebook on visualization of vector and raster files. So we will open that one, and then I will ask you to open that notebook using your Google Colab. Not there.
Not see a button.
Yeah, because I saved it somewhere else. Let me get back to you. Where is it? One, two. Um, yes. 1 second. I have it in this notebook. I'll post it in the Slack. So it's Python. Last night. Here. I'll post it in the chat. Sorry for the delay. And then you can open it to Collab, or you can have downloaded the other one and then upload it to your Google Collab. So you can open it in Collab, and I'll do that. Okay, so first cell, I will install EarthPy. And so I'm using pip install EarthPy, and I don't want to see all the comments in the installation. So I put the -- quiet. So I just run. Okay. And then I'm going to import other libraries which are already installed in Google Colab. So the other libraries, standard libraries, are Matplotlib for visualization, the operating system, NumPy for numerical Python, Shapely for all the geometries, for boxes, bounding boxes, GeoPandas as JPD, and EarthPy as ET. So it's installing EarthPy. I need to wait. Hopefully it will finish soon. Now it's ended. So I have a green mark. So I run the second one. That's going to be loading the different libraries. And also I'm going to get some data for LiDAR. So I'm going to use a library from EarthPy. So EarthPy it's going to get some data.
Carlos, can you tell us what is EarthPy library? What does that basically do?
I'm going to go back. Welcome. Just some Python library for handling Earth data.
Okay.
So this is the manual. So it comes with different packages and data sets that you can play with it. So you have the Colorado flow, for example, spatial vector LiDAR, and other. So this is I'll put it in the chat. Okay. Put early, but it's by. Okay. Okay, so I'm reading a data set there, and it's done. So I'm going to import some spatial vector LiDAR data. I'm going to import California roads from Madera County, and I'm going to import some shapes. So, and then I'm going to use GeoPandas to read the file with all these values or characteristics or variables. And then I'm going to print the value, the variable road type, and I will get back that file has different, it's a series. And then if I want to view the different values for road type, I have municipal, state, and county, and some which are not classified. Then I'm going to relabel all the missing numbers, not a number, with unknown. I'm going to replace in the column of row type, and I'm going to overwrite. So now we have 4 values: the municipal, unknown, state, and county. Then I'm going to plot using this PLT is matplotlib plot, and I'm going to make a figure of the size 14 units width and 6 on the vertical. Then I'm going to plot that file for the different columns of road types, and I'm going to add a legend and also set a bounding box and also take off the axis and show the plot. So the first plot is just the values of the roads for the Madera County in California.
The data you're using, where did it come from?
Came from EarthPy.
Came from EarthPy. Oh,
Yes.
okay.
Here, this EarthPy.
EarthPy
Data set.
has data examples or something.
Yes, so you saw EarthPy data sets.
Okay.
You saw here the spatial vector LiDAR data.
Okay.
Madera
Thanks.
County. Okay, and we continue. Now we will play with this plot to make it prettier. So I'm going to change the colors. So these are the default colors. So I'm going to change the municipal to blue, the state to green, the county to purple, and unknown gray. And this is the new road palette or new palette of colors. And then I'm going to replot the data using the new color palette. And I should get now this plot where we have defined more or less different colors, still not pretty. Then we can change the line width. So I'm going to use more lines with more width. So if you have something like this, looks like a mess. And then we will create a dictionary to add attributes. So we're going to add attributes 1, 1, 4. Municipal state will have 1, county will have 4, and unknown will have 0.5. This will be the line widths. So I'm going to stress out county roads and diminish the unknown line width for the unknown roads. So I'm going to again use subplots and then use the color palette that we defined, and we're going to change the line widths according to the type of road, and we execute. And now we should get a different plot, right? Which makes it more easy to read, okay? And then we're going to plot lines by attribute. So we're going to use this palette, color palette, and we will use in different color line widths for the state and county width 2, municipal half, and unknown half. And then we do it again, and basically we should get something that is more readable. Okay, so we have the county roads, the municipal roads, the state roads, and the unknown in very thin gray lines. So this is an example of plotting vector files. And the vector files were provided by examples in the library EarthPy, which is ET. And from the manual from EarthPy, we saw that they come with some data subsets, and we thought we chose this spatial vector LiDAR data from Madera County and all the roads. Okay, let's go. Okay. Okay, so that's vector data. Now we're going to be doing raster files. And raster files are just pixel images. And we're going to use different libraries, of course. So again, we're going to now use Volume, which is the one I was talking about for making maps, GeoPandas for handling geographical data, and NerdPy as ET. So now, again, we're going to be using spatial vector lidar data from from EarthPy, and we're going to join these two informations, Earth Analytics and data. So I'm going to execute. And then I'm going to create a volume map. So I just call the library volume, the function map, and I just need the coordinates of the map I want to create. So in this case, these are the coordinates of the U of A. So if I just execute, you will create an interactive map around the University of Arizona. It's an interactive map. You can zoom in, you can zoom out. And the base map is just OpenStreetMap, and it's using leaflet. And you can play with the map, okay? So that's just using volume. So 2 lines of code, just need the location, and by default it has the OpenStreet background map. Now I'm going to, from the spatial vector lidar data from EarthPy, California, the neon this is experimental range, San Jose, I think. And I'm going to read vector data, and I'm going to read a shape file, and I'm going to define these locations. So I'm going to read all these location paths into GeoPandas, and it's going to be these plot locations. So I'm going to execute that. Then I'm going to add vector data to the interactive maps. So here is the vector data. And I'm going to use again the volume map, but instead I'm going to change the location. So these locations are this experimental range site in California, and I'm going to use the projection for WGS 84. So here is reading the San Jose experimental range coordinates, and it's transforming into JSON file. So the map, for the volume map, I'm going to use the coordinates for that site, and also my initial zoom will start at value 14. And then I'm going to create points using the vector data from the San Jose experimental range. And then I'm going to add to the map the points. So I will have this San Joaquin experimental range. And I have the volume map, and then I have the vector points I added. And also it's an interactive map, as you can see. Well, okay. All right, so this is a combination of raster plus vector. Okay. Now we're going to
Carlos, let me ask before you go on. Yeah, the pins on the map. Where did that data come from?
these are the locations.
The locations of what?
Locations of the
SJER plot locations, JSON?
yes.
Okay.
So they convert to a JSON file, and this variable is a JSON file with the dots. Let's see.
But did the points originally come from EarthPy also?
Yes, I read the location path came from the spatial vector lidar from EarthPy
Okay.
and the California, Neon,
Okay.
San Joaquin, vector data.
Okay. I'm always like, where did that data come from? Okay, thanks.
Here, I think
Are you able to hear me through the microphone as well?
yeah, what I did something here. Something, yeah, I messed this. Yeah, I modified the code, so now it's not working.
Your
Okay.
original work.
Okay, so let's go to the next section. I'm going to install these geodata sets. So this information from different regions of the world. And then I'm going to install this other library, Contextly. And I'm going to use these geodata sets. I'm going to use a data set from geodata sets called Geoda Phoenix. And I'm going to use GeoPandas, geodata sets contextually. And I'm going to define a data frame using GeoPandas to read this geodata set from Phoenix. I'm going to use matplotlib. So AX is the plot of the data frame. Figure size, alpha is just the transparency, edge color equals black. And then I'm going to draw a base map under the plot using the Stamen terrain. So Stamen used to provide all the different backgrounds or images, but now it was purchased by Stadium Maps. So what I did is went to Stadium Maps, open an account, the free tier. So I have a couple of credit points per day. So I can use their site using an API key. So this is the code. So I have my API secret, and I'm going to post it here. And hopefully nobody will see. And then I execute.
We are recording this.
Yes, I know. Nobody saw now, nothing. And now I have this information about Phoenix by, I don't know what are the lines. And then I can do something similar using, again, these are the coordinates of, I think, I need to see. Yeah, I was Tucson. No. Yeah, Tucson, still Tucson. These are the coordinates of Tucson. I'm going to use this background map, Stamen Toner Light, and I'm going to use, again, Stadia. This is the provider, and just put here my API key, and then shoot, and I should get the map of Tucson, which is interactive. So I'm using volume again. Okay. Now,
I did not have an API key,
huh?
and I still get a result here. but no API key.
It's stored in the cache.
Is it?
Yeah.
Okay. I did it on the top one. I got
Yeah,
this.
yeah, you got your because the API is not there.
Right. And this is what it's supposed to look like.
Yeah, it's an interactive map. When you save your Jupyter notebook to GitHub, all your interactive maps just go away. The only ones that survive are the raster files. Okay, the next part of the example is to have an overlay between raster images. So we're going to install Rio X-Array quietly, and it's done. And then I'm going to import matplotlib again, NumPy, Rio X-Array, EarthPy, EarthPy Plus, and I'm going to import data from EarthPy of the Colorado flow, and I'm going to join some data. And when that's done, just downloading data from the internet, from the EarthPy datasets.
Does it then go into my folder somewhere?
It's only on the working memory.
Okay, so not on disk.
I don't think so. No, no, it's not there.
Okay.
So, and then I'm going to open the digital terrain model of the Colorado flow, boulder, Lee Hill, pre-flood, LiDAR, and an image. And I'm going to open the image using Open Raster Rio from Rio X-Array. And I'm opening the hill shade. And I'm going to open Raster. I'm just reading files, raster files, and then I'm going to plot them using, I'm going to use EarthPy for plotting the different bands of the LiDAR digital elevation model. I'm going to use this color map BDDs and the title and plot the different bands. I'm going to use a transparency of 0.5 and no axis, plot show, and I should have the LiDAR digital terrain model of a hillside in Colorado. Okay, so we have colors over the topography. Okay, let me speed up. Now, how to build interactive maps again? Volume and Rio X-Array, EarthPy Spatial. The data is the Colorado flood, and we're going to mix the Earth Analytics with data. And then create the map using volume. I just need to give the location, and by default, I'll have the OpenStreetMap for the background. Okay, and I just need the coordinates of the center of the map, and it's interactive. You can play with it, and then well, it's basically the same thing. If I say tiles equal OpenStreetMap, it will just give me again the OpenStreetMap tiles, which is the background. And then this example will overlay a raster over an interactive map. So these are the coordinate system. And Colorado flow, spatial boulder, post-flood, LiDAR, post-digital terrain model. I'm going to use an Rio X-Array to open this data set, mask it through. So I'm going to import an image. I'm going to read the image using Rio. And I'm going to plot the image. And then I'm going to scale the image 0. So I have created the image. And then I'm going to overlay that image with, again, the volume map, zoom start 13, And map bounds, this is the coordinates of the bounding box. And then I'm going to add a child to the map using a raster layer, opacity 0.7. It's a scaled image. The bounds are just the map bounds defined here. And display the map and shoot. And should get volume map with an overlay of a raster image of transparency 0.7. And you got it. Okay, so this is how you can combine. Okay. You can do the same using the Stadia maps. And of course, you have to do your API key and shoot. Okay, so we were seeing this part. Okay, after this, you have more references where you can play with. So you have a scientist guide to plotting data in Python from the Earth Lab. They have a very interesting wide resources of how to use Python in earth sciences. Very good site to visit. This is how to use Cartopy for plotting, for making maps. This is a book, and also this is another book, Geographic Data Visualization, from the book Introduction to Python for Geographic Data Analysis. So those are very major references you can continue exploring. And this, for example, gives you all the information how to plot using Cartopy. So it's very basic, like Matplotlib, and it's actually it's connected with Matplotlib. So this is a good site. And besides the one from EarthLab, so you can take different courses here. Okay, so that's what I have. Any questions?